Hey everyone, this is part 3 of your study guide review. So if you are following along in video 2, I told you to practice question 2 and then check this video for the answer. So I'm not going to walk you through this problem, but you can kind of take a look and check your work. You should have used a molar mass and a mole ratio fraction because your chemicals and what you're given and what you're looking for are different. And we see a G for grams next to NH3. So when you set up your T-chart, it should have looked like this, and your answer should be 3.54 moles of H2. So again, check your work against what I have, and remember, show all of your work. Write down your units, write down your chemicals. Otherwise, it becomes harder for you to check your mistakes and easier for you to make them in the first place. But in this video, we're going to focus on taking that skill that we learned in 1.6 and taking it to the next level. This is where we're going to change from mass A, so mass of chemical A or grams of chemical A, to grams of chemical B. And so if the given and looking for have different chemicals, remember, we know that we need to use a mole ratio fraction in our conversion chart or T-chart. And so if both the given and the looking for have grams, then that also means that you're going to need the molar mass of not just one of them, but of both of them. So you need the molar mass of both of them. And so that means if we look at this problem, it says in the following reaction, it's the same chemical reaction we've been using, how many grams of hydrogen will be needed to make 40.21 grams of ammonia? So you'll notice this is almost exactly like this question that we just looked at. Our given is literally exactly the same. However, in the previous question, it asked us for moles of hydrogen, and here we're looking for grams of hydrogen. So we'll be doing this exact same T-chart, but taking it one step further. And that's why it's important to know like when you need to stop. Do I only need to? As a reminder, when we're looking at that previous question, we know that we didn't need to keep going because what we have right here matched what we were looking for. So when they match, that puts a smile on our face because we're done. So if we look at this one, again, we're going to label what we're given and what we are looking for. And so it's the same, 40.21 grams of NH3, and we're looking for grams of hydrogen. Now, here's the thing. We see grams right here. So that means I need the molar mass of the chemical that's right next to it, NH3. And then I say, okay, well, this chemical and this chemical, these are different. And that tells me that I need my mole ratio. And then I also see a G for grams right here. Well, that also means I need the molar mass. And you might be saying, but I already am doing molar mass. Well, you're doing molar mass of NH3. Excuse me. We're also going to need the molar mass of H2. So this tells me that my T-chart is going to require 3 fractions. 1, 2, 3 different fractions. So our first step is to write them out. Because remember, if you write out all of your fractions at the beginning, plugging them into your T-chart is a lot easier. So it also shows your teacher that you kind of know what you're doing. So if you make a mistake in your T-chart, you've got, backup evidence other places. So we already calculated the molar mass of NH3 up here. So I'm just gonna roll with that. But you know what? I'll show y'all anyway. So the molar mass of NH3, if we are calculating that, we've got nitrogen and hydrogen, 1 nitrogen, 3 hydrogens. The mass for nitrogen on your periodic table is 14.01. So when we multiply, that stays the same. The mass for hydrogen is 1.01. So we get 3.03. And when we add it together, we get 17.04 grams per mole of NH3. Now, as a reminder, you have to write this as a fraction, And your fraction is kind of already in your unit. That's where that slash comes from. And there's no 1 in front of the mole, but remember, that's because chemists are kind of lazy. So as a fraction, this would be 17, let's see if I can write it over here and save some room. It would be 17.04 grams of NH3 over 1 mole of NH3. So that's our fraction. We also know that we need the molar mass of H2. Now, one of the most common mistakes that students make is they see that it's just hydrogen and they forget to actually multiply. Remember, there are 2 of them. And so the mass is 1.01, so 2 times 1.01 is 2.02. A lot of students will put 1.01 as the mass of H2 and forget to actually multiply. I've seen that exact mistake multiple times. So when we write it as a fraction, again, we say 2.02 grams of hydrogen over 1 mole of hydrogen. And if you don't remember why molar mass is equal to 1 mole, I recommend you go back and check out video 2 and just remember that it's part of the definition of molar mass, that it's always equal to 1 mole. Now remember, when we use our chart, we might end up needing to flip the numerator and the denominator in these, but we're not sure just yet until we set up our chart. And then we also need the mole ratio for this. Now, as a reminder, your molar mass, they use your periodic table, right? That's where we get these numbers from, your periodic table. But your mole ratio, you got to use your coefficients for those. And again, we review this in video 1 of this back on the playlist. And so your coefficient for hydrogen is a 3, and your coefficient for ammonia is a 2. So I can just say 3 moles of hydrogen over 2 moles of ammonia. And again, just like our molar masses, this can be flipped. It just depends on how we set up our T-chart. Notice, this is taking up a lot of space on my paper to show my work, and that's okay. You might need to do that for this problem because you need to show everything that you've learned. If you're trying to take your final exam, especially those of you who are gambling on your final exam saving you, you got to prove that you understand what this means. So show as much work as humanly possible. So we take our given and we put it in our T-chart, right? So we have 40.21 grams of hydrogen. Now remember, the rule is that whatever unit and chemical I have here has to show up at the bottom. So I know that I'm going to need to put grams of hydrogen. So I have 3 fractions. Only one of them has grams of hydrogen, and that's right here. And it's at the top, which means I am indeed going to need to flip it. I'm going to need to put the 2.02 grams at the bottom and the 1 mole of hydrogen at the top. Now, that means I've used this fraction and I can't use it again. But we see here that moles of hydrogen does not match. Oh, does anyone see the mistake I just made? Does anyone see it? And this is an excellent example. Mistakes happen, even for people who are doing this. Our given is not grams of hydrogen. Our given is grams of NH3. Now, I would like to point out that by checking back with my given and my looking for as I go throughout this, I was able to catch my mistake, and you can too. So let's go back and start over. I'm not going to re-record the video because learning and making mistakes, that's all part of the process. So grams of NH3. Okay, I thought something seemed a little off. All right, so let's start again. So if we have grams of NH3 here, then that is the unit and chemical that we're going to need at the bottom. And so if we have grams of NH3, the only place that is at is in a molar mass, but our molar mass of ammonia, which we do have to flip. So we'll put 17.04 grams of NH3 at the bottom and 1 mole of NH3 at the top. And what this allows is grams of NH3 will cancel out, And if I compare moles of NH3 to what I'm looking for, it doesn't match. So that means I have to keep going in my t-chart and use another fraction, which I already know I need 3 fractions, and I've only used 1 so far. So if we have moles of NH3 here, again, follows the same pattern. We put moles of NH3 at the bottom. And so we look for moles of NH3 in our chart. Now, I do see moles of NH3 here. However, we have already used that. So I can't actually use it again. So I need to find moles of NH3 somewhere else. And I see that it's right here in my mole ratio, and I haven't used that fraction yet. And it's already at the bottom, so I don't even have to flip it. So we put 2 moles of NH3 at the bottom and our 3 moles of hydrogen at the top. And so moles of NH3 cancel out with moles of NH3. And if I compare moles of hydrogen to what I'm looking for, it's closer, but I'm looking for grams of hydrogen, not moles of hydrogen. So I still have to keep going. And so our pattern stays consistent. If I have moles of hydrogen here, that means moles of hydrogen needs to be at the bottom. And so now I look back and I say, okay, I have already used my mole ratio. I have used my molar mass of NH3. The only fraction I haven't used yet is my molar mass of hydrogen. And look, there's moles of hydrogen at the bottom, right where I need it. So I can use that fraction in my last set. So 1 mole of H2 and 2.02 grams of hydrogen at the top. And I compare, look, we see that moles of hydrogen cancel out with moles of hydrogen. And what we have left, that matches what I'm looking for, which is awesome. That means I'm done. And so we can solve this by multiplying by the numbers that are on the top and dividing by the numbers that are at the bottom. So in your calculator, we would put this as 40.2 times 1 times 3 times 2.02 divided by 17.04 divided by 2 divided by 1. And that is a lot, I'm aware. But if you do all the work at the beginning with your fractions, it becomes just like a puzzle that you put together by the end. And so when we multiply and divide all of this in your calculator, which I just made a mistake in my calculator, and I want to point out, by writing out everything the way I would put it in my calculator, by writing out what I planned to multiply and what I planned to divide, if you make a mistake in your calculator, like you just hit the wrong button, which I just did again, because apparently I cannot talk and do this all at the same time. But if you show your work, you can get all of your credit pretty much if the only mistake you made was putting it in your calculator. So you should get 17.15 grams of hydrogen. Now, apparently, since I kept typing it into my calculator wrong about 3 times, y'all might want to double check my math and leave a comment in the video below if I made a mistake. But that is indeed your mass to mass, and that's about as hard of a conversion problem as we did this semester. So if we go then into 1.8, which is percent yield, okay, percent yield describes the percentage of a product that is actually produced after like an actual chemical experiment. It's basically the grade that scientists get. Now, the formula for percent yield, I should have left myself a little more room. Okay, so percent yield is equal to your actual amount made in grams. That makes it look like a gas. Let's just write in grams. So the actual amount that you produced in grams divided by your theoretical amount in grams times 100. So basically, how much you did make divided by how much you should have been able to make, or what was possible, times 100. It's the same concept for how you get a grade in chemistry. How you actually did divided by, in theory, how much you could have got done times 100. right? So if we read this question, it says if 63.55 grams of copper was predicted. Now, that word predicted, it tells us that that is our theoretical amount. It was calculated, it was predicted, it was theoretical. In theory, we should have been able to produce 63.55 grams of copper. And it says, so it's predicted in a chemical equation that starts with 160 grams of copper sulfate, but only 22.88 grams of copper were actually made by the students. So that means this amount is our actual amount. And you might be saying, but Miss Nichols, what about this 160 grams of copper sulfate? Do you see how it says the equation starts with this? Well, that means that copper sulfate, this is a reactant, okay? And percent yield, remember that word yield means produced, okay? We're not talking about reactants. These are all about your products in a percent yield. What was actually made. You don't make reactants, you make products. So all we need to do is say, okay, our percent yield, which remember, if you're like wanting to make sure you get as much partial credit as possible, write down what formula you're using. So it's our actual divided by our theoretical times 100. And one way to check your work and make sure you're plugging things in correctly, for example, what if you accidentally used 160 grams? Well, what I would like to point out is that when we plug this in, I'm going to put 22.88 grams of copper divided by 63.55 grams of copper times 100%. And when you see this, look, grams of copper cancel, well, if I put a U there for copper instead of carbon, they cancel out. So if you had copper sulfate in the bottom or the top, then that wouldn't have canceled out and that would have been incorrect. And so we can put this in our calculator. Now remember, the number that is on the top of your fraction goes in your calculator first. So put that in your calculator first. So 22.88 divided by 63.55 times 100 gives you 36.00%. So this scientist did not do a very good job. I don't know about you, but if I got a 36% on a test, I would not be pleased with myself and the test. And so that is percent yield. You want to make sure that your numerator and denominator have the same units in chemical. You multiply by percent, and guys, remember, so many of you would, on your test, would write this down, and then you would actually forget to multiply by 100 in your problem. Oh, and another key thing is, even though there's this percent here, do not put it in your calculator. Okay? Do not put it in your calculator. I know that if you're using an iPhone or an Android, that there's a percent sign in your calculator. Don't do it. Don't fall for the trap, okay? If you do it, it'll mess you completely up. So anyway, hope this is helpful. Stay tuned for video 4, where we'll probably have 5 total videos for Unit 1.